Hi, everyone. I'm Jake, co-founder at RootCause AI. I'm going to explain what we do and walk you through a short demo. RootCause AI lets our customers make very smart and evidence-backed and fully explainable decisions from raw data that's often scattered across several different applications or databases or files, and often even in different regions or localities. We work with data where it lives. We don't care what format it's in or how it's structured. We don't even bother cleaning it. And from the whole kitchen sink or swamp of data that our customers have, we break everything down and we even tell you why things are happening. So let's jump into the platform. Right now, we are in an organization on RootCause AI. We're hosting this right now just for the sake of a demo, but it's worth pointing out most of our customers choose to self-host RootCause AI right now. So no data needs to be shared outside of your organization. You can run this entirely in your own environment. But for now, let's create a workspace. A workspace is just a project space where you define the question you're trying to answer, and we're going to load the relevant data. So let's go call this churn rate, because that's what our example is going to be today. We're going to go upload some data. But like I mentioned a moment ago, we connect with basically anything. All of these connectors are pretty straightforward. We have more that aren't listed here. Ultimately, RootCause AI does not need heavy-duty native level integrations. We just need to be able to rip the data out of something as quickly as we can. For a quick demo, I'm just going to use some simple CSV files. So these are two different data sets. One of them is customer details for a telecoms company, and we have some demographic information. We have gender, if they're a senior citizen or not, whether they have a partner, if there are dependents, things like that. Then we also have subscription information. Are these folks using our phone service? What kind of internet plan do they have? Are they using device protection? The moment we uploaded these two data sets, behind the scenes, RootCause was looking for a way to join the data sets by identifying where they're talking about the same things. In this case, they're both talking about the same customer ID. Behind the scenes, RootCause is building what we call an ontology, or a unified map of entities, time, and locations across all of your data. It uses different statistical and semantic similarities to find out where multiple data sets might be talking about the same thing. And at any point, if you don't agree with our assumptions or the work that the platform did autonomously, you can come in and you can split the joins apart, or you can merge different ones together. Ultimately, we're taking care of a lot of this upfront, but you want to have an ontology that's been vetted by a person that you're comfortable with, because we're going to use this as the basis to kick off everything else. So once you have an ontology that you're comfortable with, we're going to move to data views, and you can see different views here. In this case, here's a combined view based on the customer ID, where we merged both data sets into a single view. And we can now use this as a launchpad from which to spin up temporal causal digital twins, or basically a dynamic, living, time-aware model of your business or of a business function that you want to model. So I'm going to go here, I'm going to click Discover Causal Relationships, and we're going to let the platform figure it out on its own. Causal discovery on RootCause AI happens in 3 stages. The first thing we do is we apply some really basic rules like time moves forward and things fall down, and we filter out variables that don't really have any meaningful connections. This creates a foundation of only the relationships that are plausible. Next, an optimization algorithm searches through the remaining variables, and we try to identify the clearest cause and effect paths while pruning away things like duplicates or weak links. Finally, the system validates the graph by producing a PDAG, or a partially directed acyclic graph. And edges are only directed when the evidence is strong, otherwise we'll leave them alone. Just by way of example, let's go pull up one of the variables in this chart, churn, right here. Right now, we're looking at all of the different variables that have knockoff effects on other variables that ultimately culminate in churn. These are the root causes of churn, according to this causal model that we've built from different messy data sets that we automatically join together. Causal graphs, though, are not static, and we have a lot of controls to make sure that you can incorporate your own domain knowledge and the context that you bring. Basically, we let you edit the assumptions in our model so you can add dependencies or break them as you test out different scenarios. So if I click on config, I can come here and I can view the different variable dependencies that we've made. Just by way of example, we're assuming that having an online backup plan is dependent on whether or not someone has internet service. You can also set hard known or blocked relationships that you want to introduce, and the temporal causal digital twin will automatically update the suit. And if you want to, you can also version digital twin, so you can simply go back to previous assumptions and versions of it as needed. But once we're satisfied with the digital twin and we've evaluated the model to make sure that we're comfortable with its accuracy, the next step is to run simulations. So out of the box, immediately upon connecting your data and launching this digital twin, you can begin to run what if scenarios, or what is the best next action I can take. We'll start with an intervention. An intervention is basically a what if scenario. Let's say, what happens to churn if I give my fiber optics customers free tech support? Our technology is not based on LLMs or generative AI, but we do think that LLMs are a great way to interface with the underlying technology. So what this query did was it simply set up the configuration for the report. You'll see here now we're setting variable changes where tech support is set to yes and internet service is equal to fiber optic. Now I'm going to go and run the simulation. Basically, what we're going to do is we're running a Monte Carlo simulation comparing before and after distributions, and we'll show the impact with things like p-values, as you can see right here, confidence intervals, and also segment breakdowns. So ultimately, what we determined here from a baseline of 30.95% and after of 20.04%, we've had a pretty significant change in churn by offering the specific segment of customers free technical support. So ultimately, instead of waiting weeks for lots of different controlled experiments or finding correlations and pruning them apart in hopes that you might get an outcome that you like, what RootCause AI is letting you do is we're showing you exactly what causes what from dozens of different data sets, all brought together and automatically put into a temporal causal digital twin that you can begin to run experiments off of. And you can simulate outcomes and understand why things change before you execute and put them into action. So that's RootCause AI, automated data joining, causal discovery, and simulation in a single platform, helping you move from correlation to real cause and effect decisions and explaining why.